think we're set up here. Hello and welcome to stream number 2. Um, Tonight we're going to be repairing a Klipsch R-115SW. This seems to be a pretty frequent failure for the Klipsch line. Actually, the R112, R115, and I don't know if there's a 10 in this series or not, but yeah, they seem to all have the same problem, and they seem to be a common failure. Apparently, Klipsch did release uh, a updated version of the amp, and that seems to somewhat address the issue. But they can also just be as easily repaired and brought back to life. So let's not waste any time and get right into it. So here we go. Just off the shelf, out of the box, R115. I don't think anything has been done to it yet. It looks to be fairly intact. But they all kind of have the same problem. And that problem starts with this resistor right here. Let's see if I can zoom in a little bit. The problem is this resistor gets hot and it generates a lot of heat, and it's within the specs of the resistor. The problem is there's a couple of capacitors that are right next to it. So as these capacitors bake and bake and bake from this thing being left on all the time, they eventually start to go. And now this is one of the better failures, if a failure can actually be good or not, that I've seen. Usually one of these caps tries to achieve liftoff and it'll actually shoot off the aluminum base of the cap. So this one isn't terribly bad, but nonetheless, it needs to be repaired, and all these caps need to be replaced. So let's get into it. First thing we got to do is we got to get all the glue off. And this is not an easy task, but it makes everything a lot easier once you start pulling the parts out. So I'm going to fire up my hot air station. We're going to set the air to about 150 C. We're just going to heat it up a little bit. This red stuff that holds on the low voltage and control wires, that, just a little bit of heat and it kind of turns into jelly. And then you should be able to pick it off fairly easily. Don't get it too hot. You don't want to melt the connectors, and you don't want to make a gooey mess. Like, the less goo that you make, the better off you're going to be. Sometimes you can take the tweezers and roll it up, and it kind of just pulls it all off. I'm working on getting some kind of fume extraction down in here in my small office. I don't know what any of this crap is made of, but it can't be good to breathe in, so it's on the to-do list. I'm still working on getting the bench organized and getting all my tools in places where I'm familiar with them, but I think I'm going to bump fume extraction up on the list a little bit, just because soldering fumes are kind of annoying. And I don't know, I don't want to be breathing that stuff in, so I think we'll do that. Try and suck some of these fumes out, and it'll probably help with all this glue too, because as you heat this glue up, sometimes it starts smoking, and I have no, I don't want cancer. I have no clue what's in that. I'm sure I could probably get an MSDS sheet if I really wanted to, but alright. This black stuff is the same thing. It's kind of a little bit more tar-like. I don't know what it is. It's not silicone. It's some sort of a rubberized epoxy type stuff. It could be like an E6000. But the best way to get the black stuff off is to kind of roll it. Just twist it up on the tweezers and it'll eventually start to stick to itself. The brown stuff is probably one of the easiest to remove. The black stuff, it can be removed, but it's kind of a pain. You really have to kind of work at it and control the heat. You don't want to get it too hot, because then it gets like liquid and it sticks to everything. You want to keep it kind of rubbery. But I mean, once you get used to your hot air station, it makes it a little easier. And I have a cheap hot air station. I got mine on Amazon. It's a Yahoo 8508D. Nothing fancy, but it works. Works pretty good. Sorry if it's a little noisy. I actually haven't previewed what that sounds like, so I'm going to have to watch this and actually listen to it. Alright. Power connectors are off. Still a little bit of glue in the corner here. I'm going to try and get it out without reheating. We got some of it. So power supply on these, I'm going to zoom out a little bit. Power supply on these is almost always good. These power supplies are fairly well built. The caps are decent. I mean, they're not tier 1, but I have not seen any problems with any of these supplies yet. And plus, they gunk them all up real good with like a hard silicone. So as long as they're working, I usually just leave those alone. Most of the problems are going to be with this amp board, and then every once in a while in the inputs, we'll get a broken RCA. And if that happens, it is a pain to get all this glue out. You know, I miss the days when, you know, these amp manufacturers use like nice plastic covers with gaskets to kind of seal everything off. It made it nice to work on. Like now, everything's just slobbered in this glue, and if something breaks, like it takes a long time to get the glue off. It's almost not worth doing the repair because everything's covered in glue. But we do this for fun, so to me it's worth it. It'll make somebody happy. They'll have their subwoofer back. We got Thanksgiving and Christmas coming, so everybody wants to have some music for their parties, if they're even allowed to have one this year. Who knows? Everything's kind of weird with that. So one of the things that I do, and I don't know if I have this handy or not, I make lists of all the caps that I have on some of these models like this, because instead of desoldering all these, I find it's easier just to clip them out. And I have it on an Excel spreadsheet, and I don't have my screen set up yet ready to share this spreadsheet. I'll do that in one of the future videos because I know I'm going to have a ton of these. Actually, I do have a ton of these to work on. I have a shelf with about 15 of them, so I will share that cap list with everybody. But for right now, I'm just going to pull it up on my screen where you can't see it. Just so I always compare the first couple I pull out just to make sure that I'm not working on some weird version that, you know, has something changed on it. I haven't found one yet, but some of the Sunfire amps that I work on have had different values of caps in different places depending on what version and when it was made. So when we get into doing some Sunfire amps, we'll go over it. It's usually on the MK2 and the Architectural series. I mean, same exact plate, but just a few components are changed on there, and that changes the rating and probably the sound of the amp. So we'll get into that eventually. But for now, we're going to pop open this sheet, check the caps, and make sure we're good. And interesting enough, all of the amps use the same amplifier board, same values for all the parts, at least for the capacitors, but they do use different power supplies. The power supplies are rated for different wattages. For the 115, it's a 400 watt supply. So the easiest way that I like to do this is I clip all the caps out. So we'll, and these are hard to see too. You need a magnifying glass. Like whoever did the silk screening on this just did a terrible job. Like everything's just so tiny and you can't read it without a magnifying glass. At least I can't. I don't have super good eyes anymore. C48 is showing as 100 UF 25 volts, and that's what I got. So get in here and we're going to snip them out. Try and get it as close to the bottom as I can. And the reason that I snip them is because all these leads are folded over on the bottom side. And it's just a pain to get these out. Like, I've tried numerous different methods to get them out, and you either end up heating them and ruining the board, or pulling out one of the through holes, or it's just a mess. So if you just clip them and then pull the leads through, it tends to be a little easier. Save some time anyways. You don't do any damage to the board. Repairing damage on the boards just makes it a nightmare. Alright, so we're going to clip all these out. This guy up here is usually one of the ones that is always bad. And some of these caps measure, they're still good, but they're not. I don't even who makes these ones that are in here. Ketuo. Ketuo. I have no clue who made them or where they're from, but they don't sound like caps that I'm familiar with, so they go. And I use all Nichicon for everything that I do. They've served me well. They seem to be fairly well rated. People like them. Most high-end equipment and gear uses them, so they have to be somewhat good. I trust them, so that's what I use. Some people like Rubicon, Panasonic. There's a lot of good brands out there. Just make sure you're using like a good tier 1 brand and not junk. If you replace it with junk, it's not gonna last. And I don't even bother turning these on to test them, because I know that no matter what, they're going to need caps replaced. So if your amp's acting up, don't even bother. Pull it out and get to recapping first. That usually fixes most of the problems on these, is taking all of the nasty glue. Now this one's actually pretty nice. I only have one spot of glue way down in the back in here, which is going to be hard to show you. Just a little bit down on there, and we'll use the dental pick and a little bit of heat to soften it up, and that'll pull right out. Getting the caps out is the caps and the leads left over for the caps is the hardest part of this repair. And they are glued together, so you gotta kind of snip them, but you can be mean with them too. I mean, they're coming out, so if you have to bend them or break a lead or whatever, do whatever you need to do to get them out. You're not really gonna hurt the board. Just don't go in there with a pair of pliers and just start yanking on them. That's probably not a good idea. So we just work our way over. The large caps I will desolder. That seems to be okay with those. The pads are large enough and they can dissipate the heat. I also desolder the resistor as well. Sometimes I replace the FET in there. Actually, I think that's a transistor. But sometimes I replace it, sometimes I don't. It depends on what it looks like and how much glue's on it and around it. If I can clean it up and it's still good, then I'll leave it in. I hope the lighting's a little better. I'm working without my really bright overhead light on, and I just have a bench light. So hopefully that will make it a little bit easier to see some of the smaller parts. The overhead light was kind of blinding for me anyway, so I like having it off. Alright. These last ones are going to be a little hard to get to. There we go, got one. If anybody knows of a pair of snips that has a really long, like skinny head on it, let me know. Because for some of these, that'd be nice to get in there without having to worry about the handles getting in the way. It's kind of annoying. We'll fold them down. We'll try and snip the leads on them. You can, just wiggle and break them too. Sometimes that's an effective way if you can't get in there, or if it's, bugging you. Just get in there and shake them, and eventually the lead will stress and break. It takes a little while, but for the ones that are hard to get to, and if you don't want to risk damaging the board, it's worth it. That snap you heard was the glue breaking, not the leads. But, you know, now that he's out of the way, that opens it up and makes it better so I can get that one down in there. So we got 2 more caps. I'm gonna go ahead and pull the larger caps and the resistor out. I'll also pull the FET too, just because it's going to give me a little better access to the back. So I will heat up my desoldering. And you need a larger tip for these ones, so I'm just going to put the biggest tip I have in, which is, I cannot read anyway, number 4. This guy's seen a lot of use. Just a number 4 round tip. If you keep your tips clean, they last a long time though. Just give them a good brushing with a wire brush every once in a while and get all the oxidation off, and then you'll get a few years out of them. Don't leave your station turned on. If you leave your station turned on, you're going to chew through tips pretty quickly. Alright, so we're heating up. We're at about 390, 400 C. A little bit to go yet. But these resistors are the main culprit. One, they're underrated. They should have been larger. I like to go with a 5 watt. That seems to be, you know, a better way to go. But also, they're not spaced off the board. They're right up against the board and right next to the caps, and there's nowhere for that heat to go. So, you know, these things sit on and they're just idle and they're just baking, just burning those caps. So it's really a design flaw. I'm kind of surprised that it was even released with that, because you would think there would be some thermal testing done. But I originally used 3 watt resistors, but now I use these 5 watts. And the 3 watts work okay as long as you space them off, but if I can find a 5 watt that has the same package, why not go with the larger one? 5 watts the way to go. And this is a PAC05. Got these from DigiKey. I think what I'm going to do is on the 115s, I'll use the 5 watts, and on the 112s, I'll use the 3 watts just until I, you know, use up all the 3 watts. But both will do a successful repair. Alright, we are heated up. Let's get these caps removed. Don't be afraid to put some heat on the board too. You know, these ground planes definitely suck up some of this heat, so it's okay to get them a little, you know, a little hot before you suck the solder off of them. You don't have to leave it on there for, you know, 20 minutes, but leave it on there long enough to get those ground planes heated up. You could throw a little leaded solder on there too if you want to make it a little easier on yourself. Yeah, like one of those legs didn't come out, so we'll add a little bit of solder. And we will suck him off again and get all that solder out of there. There we go, ready? That's much better. Alright, resistor next. Get that huge solder blob off of there. just for the heck of it, we'll measure this resistor when we pull him out just to see where he's at. I just noticed that chat was disconnected too. I don't know why it's doing that, but let's send a message and see if it'll connect. Yeah, it seems to be doing something. We're going to pop that into a new window so I can see what's going on a little bit better. There we go. Alright, resistor is out. And let's take the FET out next. And you can see some of the glue that was just baked on there. Just black and nasty. That's what's inside your amp. I'm still going to use the large tip to suck the solder out of these. It'd probably be better to switch to a small one, but I don't want to wait for the iron to cool, so it'll still do it. You just sometimes heat two of them at the same time. It will get hot, so you gotta kind of be careful with your finger. Don't burn your finger on there. Alright. Make sure that my iron or wand or whatever you call that thing is cleaned. And we will shut him off. Now the large caps are glued on. There really is no easy way to get them out. You just got to be careful, I pinch them, break them loose. Give them sometimes a little wiggle, but, you got to break the glue free. You don't want to break the board. Sometimes they'll come out. Sometimes you got to throw a pair of pliers on them and, really get in there and grab them. This one's kind of in there. There we go. There's one. There's two. Some of our lovely glue. So all this glue here needs to be removed. This whole ring here. The board really doesn't have any. There's one little spot down here by this diode that has some. And then there's a little bit back in here by this capacitor. And actually this one is a little bit different. On some of the models there's a surface mount cap here, and then they attach the electrolytic between the two legs of the surface mount. This one just has the surface mount going right in. Alright, let's finish pulling the caps out. We got this one guy in the back here. I'm going to set him aside too. Well, let's look up his value really quick. I have my sheet open. That is... Okay, that's good. 22 micros at 50 volts. Alright, let's measure this resistor. I said we were going to measure that. Let's see where we're at. Chances are it's probably still good. This one doesn't really look too bad. Well, it's got a crack in it, and the ceramic's starting to flake off. I'm not going to zoom in. Yep, this resistor is toast. Let me get my finger out there just to make sure it's not me. Yeah, it's not even reading. It's open. It actually failed to open. Get the meter in there a little better. 1.8 meg. And that's actually reading my fingers because I'm pinching the leads on there. If I let my finger off, open. Not good. Let's get our new one, our 5 watt. We'll measure him. Should be a nice 820. Close enough. So, yeah, we can see why this amp wasn't happy. I believe that resistor feeds one of the lower voltage supplies. It's part of the, yeah, that's part of the switch for the PWM controller, which is this guy back here. So the transistor must be the switch, and they're either using that resistor for current sensing, or is just some kind of loading resistor. I don't know. I don't know enough about the circuit to tell you how it's being used. I just know that it's bad and needs to be replaced. So next comes getting the glue out, and this is going to be kind of hard to show everyone. Let's see if I can do it on an angle. I'm used to doing it with the amp in my little amp stand, but we'll see if we can do it with it standing up. If not, just kind of watch how I do it and follow along. Again, we're going to be using the hot air, low heat. We'll start with the dental pick. Actually, I'm going to try and quiet down my hot air real quick because that's kind of annoying, and I'm guessing that the microphone can pick that up. Stuff a rag under there, that should help. It has rubber feet, but the rubber feet sure don't seem to do a whole lot. Yeah, that's a little better. At least it's not rattling like crazy. So we're just heating the glue, getting it to a soft state. You don't want to melt it, we just want to soften it up. Then we take our dental pick and just carefully work it off all of them small surface mount parts. We want to get it off the surface mount parts because eventually this glue is going to become conductive if it hasn't already. And what's going to happen is it's going to blow another part of the amp, so it's best to just get all this crap out of there. When we're all done and we want to secure our parts, we'll put a little silicone in there and we'll make sure it doesn't get on the board. So sometimes this glue you can wrap it around the tweezers and just kind of twist it off, and it'll follow the tweezers as you roll it. Let me see if I can zoom in a little better. a camera behind me kind of looking down in there. That would make it easier. We'll have to try that. For now, this is what we have. I apologize for getting my head in there. I'm just trying to see what I'm doing here. Come on, focus. There we go. But you can see that as the glue gets warm, it softens up and it just pulls right off. Like, it gets kind of sticky as long as you don't get it too hot. Alright, I'm going into my stand. Make this a little easier. I'm going to keep pulling this glue off. Prop it up a little bit. That's too much. I'll try and figure out a way to keep this lean back, because that's a fairly good angle. And I can work at that angle. I need a kickstand, that's what I need. I need to make a little amplifier kickstand to hold them right there. I do not see anything to easily do that with. Yeah, some of this glue was definitely starting to turn brown on these. Get pretty nasty. I wonder if I could easily take the supply off. Nope. Just bear with me while I get this glue out of here. Since this one isn't too bad, it won't take too long. Oh, we're just applying some heat and peeling off glue. And anybody that's worked on one of these Klipsch amps before knows that the glue is one of the killers for these. It's actually the killer of a lot of amps. A lot of amps suffer from glue death. It's pretty well documented. The Bad Caps forum has some information on it. I'm sure a lot of the other websites and forums do. I don't know what they put in it. I don't know why they used it. Well, I know why they used it, because it was cheap. Silicone's probably more expensive than garbage glue, and garbage glue is what was used. Got 3 more little spots to go here. Again, don't be afraid to put some heat on there, you know, just don't get the glue to the point where it's soupy. You want it to just to get kind of rubbery so you can let it stick to itself and peel it off. If it starts to get soupy, you're going to have a really hard time getting it off. And this is one of the easier ones, so I'm sure we'll have at least one that's going to just be covered in glue. This one was probably made on a Friday. I just wanted to get out of work and didn't care. Which is okay with me. If they were all this way, I would be extremely happy. And most of the time that's taken on these repairs is the prep work. You gotta do the good prep work. If you just, pull everything off and just smack some new components on, whoever you're doing this for is gonna eventually call you back and be like, "What the heck, man? I thought you fixed my amp." And I've had, you know, amps come back before. Sometimes you miss a few things. It's hard because there's no schematics available. At least not that I've found. Alright, I'm removing the glue around the power input connector for the high voltage supply. Just trying to get as much off as I can. You're not going to get it all, but get it all off the components. The connectors really isn't too big of an issue. I'm just OCD, so I try my best to get it off everywhere. So there's where we're at so far. I have this cap glue off. I have that little bit. I have a little bit back by these components here, and then there is a couple of small dabs in this area that needs to go. Actually, I have an idea for an amp stand. Really, we just need something behind it that won't move. So we could throw a box back there. Just lean it up against that. Try and hide the name on the box there. Alright. Oh, amp stand. Not elegant, but functional. Gives everybody a little bit better view how tedious this is to peel off this glue. But you don't really have to get it off of the inductor on the side. I mean, you could scrape around it, but there's really nothing over there that you have to worry about the glue shorting out to. And don't get these film caps too hot either. You don't want to bake those. Just, get the glue kind of heated up and coming off. Be going there with the tweezers, give it a little twist. And then let it be. That's not going to hurt it over there. If the glue hasn't started to turn brown by what you're cleaning, then chances are it's probably in an area that you're going to be okay. Temp is a little bit hot on my hot air. I'm at 140 C. I'm going to turn that down. 125, 120. It's really not too hot for the work, but it's burning my fingers. If you have any big blobs, just try and snatch them out of there. This area doesn't really matter, but do the best you can to clean it up. Don't do a halfway job. Be gentle too. You don't need to go in here and scrape it off the board with the front of the pick, because there might be traces back in there. Take your time. That's the most important part. Take your time. It's not a race. If you get to the finish line and your amp is repaired and it works, then you're a winner. Doesn't matter how long it took. Alright, next area we are going to do is back here. Now, once in a while, this film cap here will go bad, and I have seen that. There'll be like a little hole burned in the front side. Extremely uncommon, but it has happened before. I don't know why it happened. It could have been, power surge or a spike, or who knows. But doesn't hurt to give your stuff a once over just to kind of see what's going on. So this glue was starting to turn brown, so eventually we would have had some problems over here. So we got it loosened up. We're going to go in with our tweezers. Just kind of give it just a little scoop. And then twist it off. Careful around the diode. Don't shatter your diode. It is glass. Give him a little extra heat just to make it come off easier. We got most of it off. Just a couple little blobs still. There it goes. One more little bit by the film cap. We should be good. Oh, there's one more spot. One more spot by the thermal sensor. I apologize for the focus going out. It's just hard with my head keep getting in the way, and the weird angle of the board that we're working on. Be kind of gentle by the legs of the thermal sensor. Don't get in there and break them off. Clean around them, but you don't need to yank on them. There we go. Nice and clean. We got one spot here by the film caps. Just do a little tweezer twist to kind of pull it off of that surface mount resistor. Can leave it on the top of the caps. That ain't gonna hurt nothing. It's off the board. Off the board and out of the way. The side of the caps, if you can get it off, get it off. If it's fighting you and giving you a hard time, leave it on. Like this little bit here that's on the top, like if it'll come off, pull it off. If it won't, leave it. You don't need to keep adding heat to the film caps. They don't like it. Here's our last little bit of glue right here. This most likely was a factory drip after they slobbered it on all the other stuff, so. There we go. Let our hot air cool off. Give it a quick little once over. And that's what it should look like. Nice and clean. No gunk on there. No glue buildup. Ready to have the leads of all the caps pulled out. And then we can start recapping. Alright, let me zoom out. This should be a little easier to see now that we're working on the bottom of the board. Alright, I have some additional light. There we go. Wand light to the rescue. So this part's kind of a pain too, pulling these cap leads out. But what I have found is these mildly magnetic steel tweezers. And they're made by that company there, C-Tex. Work great for pulling the leads out. And these are stainless steel, but they stick pretty good to a magnet. And the leads of our caps have steel in them. They're actually steel wires that I believe are nickel plated. So we want to pull them out. Just heat up the pad. Get your tweezers in there. And the lead sticks right to it. Pull it off, go on to the next. It's great. Now, I will have to use the solder sucker and clean out all these holes, but for getting the leads out, this is great. Sometimes on these ground ones they're a little more difficult, because this board does have one big massive ground plane on the bottom. Just give it a nice big solder blob. Get it heated up. Stick your tweezers in there, and there's your lead. No damage to the board. That's what you want to avoid, is doing damage to these boards, because it's hard to fix them. I don't know how many layers. This could be a multi-layer board. I'm not sure. Well, when you do it like this, it's pretty easy. Try not to burn yourself when you're pulling the leads off too. They are fairly hot. So we go through and we'll knock those out. Pull all the cap leads out, and then we will start replacing them. When we do that, I work from the back to the front. Sometimes you might have to give it a little more heat with the bigger iron. Put the solder sucker on there because sometimes they just don't want to clear. Again, I'm not, slobbering this thing with flux. You don't really need to put a ton of flux on here and make a mess. Sometimes when you're soldering them back in, it's helpful, but when you're pulling them off, just, if you use a thick rosin core solder, there's enough flux in there to, get you the little bit of cleaning action you need to pull these parts off. Surface mount stuff, that's a different story. Surface mount, you almost always have to use flux. But, it's not terribly hard to do. It's just tedious. Take some time. If you're mildly good with a soldering iron, you should be able to repair your unit. But you need to have a solder sucker. If you don't have a solder sucker, I wouldn't even try it. I guess you could go through each one of these with wick, but then you will have to flux the board, and I don't know. I wouldn't do it. It's too risky. If it was my board, it'd be a little bit different, but I don't want to make the extra work for myself having to replace through holes and tracks and, whatever else gets damaged. Some people are really good with solder wick. I am not one of those people. And I keep flipping the board over to check and see which ones I still have left to go because I have not memorized this yet. I've done enough of them I should have it memorized, but not yet. We'll get there though. I always forget to shut my multimeter off. Cool thing is I bought rechargeable 9-volt batteries. So I can leave it on and it doesn't matter because I can just throw a new battery in there. Pretty neat. They're lithium ion too. So for like test equipment and stuff that kind of sucks the batteries down, they're nice to have. Let's see, we have 4, 5 more. And those 5 are back here. So we'll get all these legs out. We'll clean the holes using the Weller with the DXV80. And then we'll start popping the caps back in. I'll show you how I place them, how I place the resistors. You know, space it off the board and kind of get it out of the way. And then hopefully we can fire this up and give it a test. Guess I probably should have plugged it in beforehand so we knew it was dead, but I believe the guy that sent it to me. If he says it's dead, it's probably dead. And if any of you listening have one of these amps, you'll know it's dead, so. Yeah, like right here, two leads folded over one another on a ground plane, that's kind of hard to get out. We might have to put some heat in there. Try to just put a decent sized solder blob on there and see if that is enough. I got one. Let's see if I can get the other one. There's a lot of thermal area there, though. You could see it's cooling the big solder ball I have before I even pull it off of the board. Big ground plane. So we got the rear, we're waiting on the front one here. Yep, he ain't gonna come out. So we'll have to use the 100-watt solder sucker. That'll give us enough heat to clear it. So we need the two caps that are in front of the transistor, and then looks like I missed a leg on one of these middle ones. Right there. Maybe two legs. Maybe what I'll do is I'll take a picture of this and circle all of the caps from the bottom side that we actually take out. Then when it's time to actually pull the leads, all I'd have to do is just look at the reference image, and I wouldn't have to keep flipping the board over, trying to figure out which ones I missed. You can always modify your technique to make it better. It took me a while to figure out that this was easier to snip the caps and then pull the leads and then desolder it than trying to do it all in one shot using the solder sucker to bend the leads up, heat them, bend the leads up, then clear it, then make sure you cleared the whole via, then pull the cap out. I've damaged a few through holes like when I was first working on these and learning how to do them, and everything's so densely packed in there, it's a pain. They could have made the board like half an inch taller and gave everything some breathing room, but that is not the case. And maybe there's not enough room. I don't know. I've never seen one of these units complete. Maybe the subwoofer's actually in the way. Alright, we look pretty good. I do not see any that I missed. So, shut the iron off. And zoom out. And we'll start clearing these holes. We're gonna put a smaller tip in. We don't need the massive tip. I'm gonna go to, I think, a number 2. Yeah, we'll use the number 2. It's actually kind of interesting streaming a repair of these because I never tracked or timed how long it took to do one. So I can kind of follow along just by how long the video has been. So we got about an hour in so far. I find that interesting. I've never really thought about how long it takes or how much time I spend actually working on an amp. I guess I understand now why some repair shops charge like $200 for a repair. You got 2 hours tied up into it with materials, and you got a overhead cost that kind of justifies it. I just do this for fun though. I don't, I'm not running it as a business. I'm just doing it as a hobby and something that I enjoy doing. There seems to be enough demand to run it as a business though. I guess if I ever get laid off, my prices are going to go up. All right, we're heated up. I'm going to clear out my hole in my tip just in case I have some buildup in there. And for that, the best thing to use, just take a cap that I have in my little bin. That one is too big. Find one that fits and use that to clean it out. Eventually it'll get soldered in, so that little bit of solder that you're going to get on the end, that doesn't hurt nothing. Alright, we will start from the bottom and work our way forward. So we'll start with the difficult one that I couldn't get out. And bear with me, I'm stuck on my headphones. There we go. Alright, we're going to start in the back. Well, this is where that one lead was stuck, so we'll use the stronger iron to heat them up, and hopefully I can pull it out. There it comes. There it is. Those big ground planes are no match for this beast. Alright, those 4 are clear. Now we have the back one. I might be able to do this with this laying down. Get a little bit better of a view. I don't think that's any better, but it's a little bit easier on me. And it's nice too. You can hear when these holes clear. It's like, it sounds like a little kid trying to suck something through a straw when it's empty. It has that kind of gurgling sound. So you don't really have to keep an eye on it. You just listen for it. And I like this number 2 tip for this kind of stuff. It seems to work really well. I have a longer number 2 or number 3, and that one's good too, but this smaller one seems to get much hotter. So you can see the time that this saves having a vacuum desoldering tool. If you were doing this with one of those plungers, I mean, your hand would be numb already. All right, that second row, we have these 3 going across. So every once in a while, you're going to run into that, or there's just not enough solder on the top to get it to melt all the way through. The easiest way to correct that is just to smack a blob on there and pull it back out. Now, anywhere where there's a shared um, connection, where you have 2 through holes right next to one another and they bent the leads together, I always straighten that out. I don't want those 2 wrapped up against one another when I put the new part back in. One, because if they, ever have this amp recapped again, it's just going to be in the way, so just bend it out of the way. I mean, I believe the only reason that they do that on these is for assembly. They throw all the parts on and then send it through a wave solder machine, and I think the bends keep the pieces in place. But it's a tech nightmare. I think if these leads weren't bent on this, I would have been done a long time ago pulling those camps out. Alright, I have, I believe, 2 more. 2 more, and I didn't pull the leads out of those 2. So I have this guy back here. And you can use the desoldering tool to pull the leads if you want. It works just as good as the iron, if not better. Sometimes I find it's a little bit too big to get in there to actually get the heat on the pad. But it is nice that it's hotter. It does make it a little bit easier for the tweezers to pull them out. You could probably do this with a magnetic screwdriver too. I mean, you don't have to use special magnetic tweezers. I just kind of got lucky and these happen to be magnetic. Yeah, there's a cap we pulled out of this guy here. I forgot. Actually, no, that is a factory. Oh yeah, we pulled that one out. We missed this one over here in the corner. These holes just need to be cleared. Guess we need the light to see. Alright, last one. Pull him out. Off we go. I'm gonna print out a cap list. The reason I'm gonna do that is I want to make it easier for everybody to see what's going on. Now, my numbering on these aren't, well, I'll have to explain it as I go through. Some of the silk screen, you can't see what the numbers on it are. So you kind of have to get creative and play around with the name a little bit. So I'm going to step out really fast and go grab this off my printer. I'll throw up a be right back and give me about 2-3 minutes and I'll be right back. Alright, so now we got our cap list. And let's see if I can get that on the camera and focused in so everybody can see it. It's a little difficult using this different light. Oh, hopefully it's kind of readable. Let's see if I can zoom in. Just in case somebody's got a, yeah, there we go. That seemed to focus pretty well. Hopefully everybody can see that, and if you have one of these blown parts, you can replace it. Anywhere where there's a BP, that's a bipolar cap, non-polarized electrolytic. And some places where I couldn't see the silk screen, you know, I'd just put a label like the C by R40. So you look for R40, and that's going to be the through-hole cap that's by R40. All right, here we go. Rebuild phase. This is the fun part. So I like to start in the back and work my way forward this way and then out. So the first two I am going to work on, and I have to use a magnifying glass because they are so small. That's kind of interesting. You can kind of see it on the camera, except it's backwards. C29 and 30. C30 being in the back. So C29 and C30 are 47 at 25 volts. And those are polarized. So I have bins, and they're in the back of my workbench, and they're just full of caps, and they're all labeled. And all of my frequent high use ones I keep in stock, and then if it's an oddball, I'll have to order it in. The ones that I use are Nichicon, and they're the PS series, UPS. I like these caps. I just think they're good caps. They're good general purpose, and they work great for repairing these amps. Sometimes you'll run across, certain models. They have special audio grade caps, on certain parts of the circuit. And if they do, then I use the Nichicon Muse series. Those things are expensive, so I don't see a need for using those on just a general repair when, anything's going to be better than I can't even pronounce this, Kitoyu. Anything's going to be better than a cheap Chinese cap, let's put it that way. Here we go. Polarity is marked. Your negative side is going to be your white semicircle. So, again, we're doing 29 and 30. I'm going to pop those in there. There's 30. And there is 29. So I don't push them all the way down to the board. I like to leave them standing proud a little bit. Let the leads, just kind of start to spread out, but leave them off the board. This way you can bend them out of the way and get them away from any sources of heat. It's going to make them last longer. Let's see if I can get a view of that. So they're not all the way down to the board. They're floating a little bit. You want to let them float. If you push them all the way down to the board, one, you're going to stress the leads because the lead spacing on these is not made for that. And two, you're not going to be able to move them. And we want to be able to move these so we can get them away from that resistor because that look good. Well, I think my internet just dropped out. It says we're still there. Yeah, we're good. We're still there. All right. All right, we'll get our two leads in. We'll uncross the two that are in the middle. Now these are ground plane leads. So I'm going to put a blob in there. But we're going to come back and fix that later. Just get them in place, get a little bit of solder on it. And anywhere where there's a big heat sink and the solder doesn't sit down on there nice, we're going to use the solder sucker and we'll clip the leads and then we're just going to heat it up and we're just going to dab it on the pads, and that'll make sure that we get a nice solder joint and it'll leave us with a nice fillet too. With soldering the ground or the leads that are tied to the big grounding planes on the board just need more heat. And you could sit there with the iron and heat them up enough to get it on, but it's just easier to use the higher watt desoldering tool to solder them. Alright, next cap is all the way in the back, and then it's going to be C69. As we're going, we'll cross the ones off the list that we did too. That makes it a little easier. 29, 30, 69. 69 is a 10 microfarad 50 volt bipolar. And I happen to be out of those. Alright, well, we'll skip that one. Hopefully I have some in my spare parts bin. On to the next. And I have a parts order that needs to go out, so it's not the end of the world. Next will be C1. C1 is a 4.7 50 volt bipolar. That one I do have. And I still try to arrange the bipolars all in the same direction as a polarized. So if you look at a polarized, the longer lead is your positive lead on a polarized cap. So when I'm putting a bipolar in there, I'll put the longer lead in the positive. Now, I don't know if it matters in these circuits. I know that with tube style gear, I know if some of you've listened to Mr. Carlson, like he's pretty adamant about making sure that the outside foils are properly placed. I would assume that the electrolytics function somewhat the same, so we're going to put the negative where the negative should go. I don't know if it matters in a solid state amp, but doesn't hurt to do it anyways. Just get used to doing it, and then if you're working on a amp where it does matter, it's already programmed into you to do it that way. Again, spacing it off the board so we can move it out of the way. And I fold all the caps over, and then I'll just put a little dab of silicone to kind of group them all together. The silicone's a lot better than the glue that they originally used. Next is C42. Let's cross off C1. C42 is also a 4.7 bipolar. Again, make sure we check the arrangement, match it up with the other one. I am sure that I have put them in wrong before, and the amp still functions just fine without any hissings or hums or buzzes. But they do have these marked as polarized. I don't know if that's because the layout software they were using did not have silk screen for non-polar caps. I don't know. I don't know why they did it that way. All right, C54 is next. C54, and that one we just did was 42. 42, we'll do 54. 54 is 22 microfarad, 50 volt polarized. $22 50 volts. A lot of Klipsch amps do use the same capacitors, so once you do build up a little stock of these parts, you can work on a number of different amps as long as you keep parts on hand. I've gotten to the point now where I order them, 100, 200 parts at a time, just because I go through so many of them, especially 4.7 50 volt and 47 50 volt. Those seem to be the hot item for all the amps. Next, we're going to start working our way out now. C43. 43 is 125 volts. And I'm sure if we dug through here for the 125, that's the ones that are a little bigger. I'm running low on those as well. I think we only need 4. I should have 4. C43, yes. Now these came with leads already trimmed. I prefer to order them that way if I can. It's called the bulk package. It makes it easier than having them come on cut tape. Not all of the values are offered that way. Just seems like some of the more popular ones are, but it's nice to get them with the leads already trimmed. Just a little easier to work with, and they take up a lot less space in the storage bins. So this is going to be one of those ones where the ground plane's going to get in the way, so we'll just kind of put a blob on there and go on to the next one. Next cap is C44. 100 UF, 25 volts. I apologize if this thing keeps going in and out of focus. I keep moving the board around and the camera's freaking out. I should just do a fixed focus on there to eliminate that, but now make sure you pay attention to your polarization on these two. Which side has your white mark on it, because these two are backwards from one another, and if you're rushing, you put it in the wrong way. You leave it on for a couple minutes and you'll get a nice little pop in there and your cap will be destroyed. Not the end of the world, but just if you pay attention when you're doing it at this stage, you don't have to go back and redo anything. And it doesn't hurt to take some pictures either if you want. You can take a picture of the board and how everything's kind of placed and what the values are. Because I've done enough of these where I just have all the values on a sheet of paper and I can just kind of plug through it. Everybody's going to have their own style of doing it. So once you develop, your own technique and what works for you, just kind of stick with it and then you'll get better as you go. So next to C44 is C39. 39 is 47 at 25 volts. It's also a fairly common part. Sub 10s and 12s, certain versions of that use a 25 volt. Some of them use a 35 volt. When I'm working on those, I try to replace them all with 35 volt. And you can increase the values of these too. Like, I know some people, when they replace caps, they always like to go like 1 voltage tier higher. It won't hurt anything to do that, but I don't think the problem with these is voltage related. I think it is heat related. So I don't see a need for going up to like a 35 volt cap. As long as you're using a quality cap, you're going to be alright. If you're using a junk cap, then you're probably going to have issues. Don't use junk caps. Alright. Next cap. And we're halfway done at this point already. Most of the time is the prep work. Getting the prep work done. C56. 10 UF bipolar. Actually, we don't have that one because that's 50 volts. So I'm going to circle those two. And if I don't have them, I'll throw anything I have in there. I'll put a 22 in there, or, you know, a different value. Done. I keep getting notifications that OBS is dropping out, but it seems to be functioning okay. Could be an internet thing, who knows. Alright, let's continue. We are going to go to C48. That is a 100 at 25 volts. Again, it would be nice if the silk screen was a little easier to read, so I didn't have to get in here with a magnifying glass every time and double and triple check everything. I like that idea of making a little printout guide so I know where to pull the legs at and what parts go where. I'll probably do that just to make it easier on myself. I do have a lot of these to do. It's tedious, but I don't know what these systems were, but I'm told they're pretty good sounding systems. These Class D amps are usually pretty good. My favorite amp of all time, though, from Klipsch is the Sub 12. I think that thing is a beefy amp. Well designed. I mean, they all have their issues, but the Sub 12 is my favorite. It puts out a decent amount of power. You can use it for, you know, DIY applications. I think the Bash 300S is like the Parts Express version of that one. Seems to be a pretty popular amp of it. If I had to pick my favorite one to work on and my favorite one to use, it would be a Sub 12. My home theater sub for many years was a RW10, not the digital version, the old analog version. And that was a pretty good sub, and it still works. I had to do a repair on the power supply on it, but it still works. Just ready for something different. I haven't quite decided what route I want to go yet. I'm thinking about going with a Sunfire. I kind of like the MK series in those, and I have a bunch of them that I need to fix, so that might be what I end up using. That's a ways away, though. I have a lot of renovations to complete before I set up my theater again. I do miss it, though. It was nice. Action movies and surround sound, you can't really beat it. So finishing up on the small caps. Again, we're not really trying to make the solder joints look pretty at this point. We're just trying to get them fixed in place. You know, make sure our values are correct. Make sure everything looks good. We're leaving our caps spaced off the board. I'd say probably 5 millimeters. And I try to use the metric system, even though I live in the States. Like, metric's just better for everything. Some people will disagree, but when you go to buy a capacitor, they don't sell them in inches. And they're nice round numbers, 5 millimeter diameter, 8 millimeter diameter, 10 millimeter diameter. It's a lot better than trying to figure out what a 16th or 32nd of an inch would be for a tiny little part. Alright, let's check our FET. He's going to go in next. And all we're checking for is shorts. So obviously the heatsink is shared with the... But if it's not shorted, I've never had one of these that's been bad that was not shorted. So obviously we should get, you know, close to 0 ohms there, but everything else should be open. Or really high, 5 meg. Like, that's a good part. We don't need to mess around with that anymore. But it doesn't hurt to check it. I used to replace those, but they clip the leads really short. But I found that when you put them back in, if you just let it lean back until it can't lean back anymore, that's enough to keep it out of the way of the resistor. So this would be about sitting straight, and that's leaned as far back as it'll go. And it's almost touching that cap behind it, but we're going to bend that cap out of the way anyways. So we're just going to put him in there and lean him back. And we're only going to do the outside legs. And you can bend some of these legs out of the way if they're starting to bug you. And you can throw a little bit on the inside leg too. Make sure that, you know, you got a decent amount of solder in there. Don't get it over the hole for the resistor. That's coming up next. So I'm going to move my kickstand box. And now we need our big caps. And these are 1000 micro at 80 volts. And I need to find them. 1000 at 80. 1000 at 100. And I know I have the right caps for it. I just don't know where they are because my bench is still kind of in chaos. Actually, it's really not in chaos. I just don't know where everything is yet. So bear with me while I check my drawers. My capacitor drawers, that is. My regular drawers are just fine. 470 at 100. It is possible that I am out of these as well. Nope, here they are. 1000 at 80. So I'll have to make sure I label that bin. So you can see original Katuo cap, Nichicon, and these are PJs, UPJs. Same diameter. I try to keep them the same diameter, but I mean, you can just tell that this is a much higher quality cap. It's built better. It's got some mass to it. It's got a better temperature rating on it. What is this rated for? They don't even put the... Oh, yeah, alright, so this is a 105C rated. As well as this one, but I don't know. This is a better cap. Go with a Nichicon. They have served me well, and they will continue to serve me well. Actually, you know what? Before we put those in, we're going to put that little one in the back. That's a pain to get to. I believe that is our C by R40. And that one is marked. There's a little plus sign on the board. The little plus sign is on this side. C by R40 is 22 microfarad at 50 volts. That's another fairly popular size. 22 micro at 50 volts. So far I'm liking this wireless headset. Seems to be alright. It's a little uncomfortable wearing it for a while. It's like digging into my ear, but not having my ears blocked and being able to freely move around is quite nice. It's just a cheap little VHF battery-powered headset. Seems to function though, and has good volume range. So far, so good. I guess when I listen to the video, I'll know if it's good or bad, but the preview sounded alright, so hopefully everybody can hear me. If not, I apologize. It'll be like one of those really awesome informational videos from somebody overseas that doesn't speak. Although I think you should be able to follow along without hearing me ramble on. Alright, I think we are ready for the large caps now. Large cap time. Again, make sure you check your polarity on these. You don't want to blow up your large tank caps. These are the expensive ones. Especially when you get into the really large ones on some of the different amps. They start to add up, $5-6 a piece. You blow one of those up, it's not a good day. Get these in nice and square. Again, we're just kind of tacking them in place right now. We're going to go over it again with the solder sucker and higher wattage and really get them seated to the board. You know, verify your polarity. If you got to second guess it, you know, heat it up, pull it out a little bit, take a look. Okay, that's my negative. We're good. Pop it back in. Doesn't hurt to verify your work. Everything that's being done so far is redoable and undoable. So bend those out of the way. Throw them in the kickstand. So now we're going to put the... Well, let's put the two smaller caps in first, next to the FET. And that is... This one is marked as C80. I don't think that actually is C80, but we're going to call it C80. And the other one is C19. Those are both 22 at 50 volts. There's one oddball on here. That's usually the one that I do last, and I do something a little different with that guy, so we're getting there. The reason I want to put these in first is I want to make sure that I have plenty of room to get my resistor out of the way. tack this guy in. Check our polarity on the other one. This guy, all these are going to get folded over as soon as we get the last one in there, so that makes a little bit of room to try and keep the heat off of them. Because that seems to be the failure point. Either the caps get hot and fail, or the resistor dies. So now we have all these are in here. So I'm going to take a toothpick and I put it down by the bottom. Or a stick, you know, if you have a little working stick that you like to work with, or, you know, however you want to do it. But just kind of support the leads at the base and bend these caps over. If you can't get in there, grab your dental pick. You got to have a dental pick. If you're going to be working on this kind of stuff, you need to have a pick. Pick is important because you can reach in there and get the get into small little areas and help control your bends and things like that. You don't want to just bend it over because it's just going to fold the leads at the base. You want to kind of roll the leads over. So it doesn't have to be anything fancy or super pretty. Just just roll them out of the way a little bit. And this guy over here, same thing. We'll support the leads at the base, fold him down, fold this guy in, and now we can put a little blob of silicone to tack those two together, keep them from vibrating. The ones in the back here, I mean, you can fold them over too. This one behind the main caps, I just push him back. These two over here. Get in there with your dental pick and just kind of flop them over. Just want to get them out of the way. So that's kind of what it looks like. All the caps that were nice and straight now are now all crooked and snaggle-toothed. But we did this for a very important reason. And that is so this guy can breathe. So I already pre-bent the leads a little bit. Just kind of shaped them so I can get it to fit into where I want it to go. And you're going to have to tweak them a little bit. I haven't used these larger resistors yet, so there's going to be a lot of tweaking, I believe. But these larger ones can dissipate more heat, so that's why I want to use them. They should last much longer. Leave some space in there. You don't want it rubbing against the sides of the resistor because these are wire wound. So you got to get in there and, rebend them. Take your time, rebend them. Make it look nice. Alright, so we have our resistor in the hole. This guy is much larger than the 3-watt, but that's okay. What the goal is to get them in there and then get them away from everything else. So if you got to twist it a little bit, maybe put a couple of little bends in there, however you got to do it to make it fit. But make it fit, and we don't want it to go too far into the board. We want the leads on this to just penetrate the board far enough to where they would be as if you put them in there and then clipped it. So this is going to be like a permanent install. We're not going to change the leads. We're not going to clip these leads. Like, we're just giving it the bare minimum, sticking through the board to where we know it's going to be fixed. We will hit them again with the big soldering iron just to, you know, make sure that it's in there and keep that thermal pad kind of cool. But, so we got it in there. Now we can, you know, once your solder sets up, now we can kind of tweak it and move it around a little bit. And, you know, I'll give it a little twist, you know, lean it. We want it away from the resistors as best we can. I'm sorry, the capacitors. So that's kind of out of the way. Really, with this board design, that's the best you can do. If you wanted to be crazy about it, what you could do is you could mount the resistor to the back plate. You'd have to use like a metal resistor clamp it to the back plate so it has some heat sinking, and then run 2 leads off the resistor and into the board. It's going to require you to drill a hole through the board. That would probably be the best way to do the repair. If this was my amp, I would do that, but some people, you know, they don't want you drilling holes through their, you know, really nice clean plate amp, so I just kind of do my best to make it factory, and we go from there. You know, keep an eye on everything, make sure that it's good. Keep these caps away. Now there is a cap that does go underneath the front lead of this resistor here, so I might, you know, still do some small adjustments on there. Maybe, you know, bend this lead out a little bit to give it a little more lift. Get it away from this guy. You know, just play with it until you find something that works for you. And that is our oddball cap 2. That's 330 microfarad at 16 volt. It's a little bit bigger too, but what I like to do with these is I will use a medium stick, which I don't seem to have right now. We'll use a screw. We're going to bend the leads over, so we give it a little strain relief. Get those leads bent out of the way. And then we're going to pop them in. And, you know, make sure you bend the leads the right way. I bent them backwards. I like to put this guy facing this way. We'll use our little pliers, straighten them back out. Grab our bolt, fold them back over. And the reason that I like to put a little radius in there is that gives you a little adjustment room back and forth. Kind of tweak it a little bit. You can put it on the bottom of the board too if you wanted. You know, yeah, actually, let's do that for this one. No, he'll fit. We'll put him on the top. I already bent the leads back. But if you wanted to, you could put him on the bottom of the board, and that's perfectly fine. So you have 2 leads that are kind of close there, but he will be well out of the way of the heat. And we'll tweak, we'll bend that lead for this resistor to make sure that he stays away from that guy. But putting him on the bottom of the board is a solution too. Personal preference. Tack him in place. Now we will address our resistor lead. And that's really not close enough to where it's going to matter, but you know, just for the sake of being thorough, we'll bend them out of the way there and, you know, make sure that everything's going to be happy. Give it a twist. All right, I'm pretty happy with that. It's off the board. It's away from the caps. There's plenty of space in between that lead, and I will put a blob of silicone down in there just to make sure that they can't touch. You know, silicone's a pretty high temperature material, so that should be happy. So before we go any further, we're just going to check to make sure that our caps are all facing the proper direction. Kind of an important step. And, you know, we do remember that we are still missing two. But we'll get to those last. And my dog came to say hello. She's still a little camera shy, though. We'll work on it. Alright, so now we're going to clip the leads. And don't clip them so they're, you know, too low. You need some room to be able to get to get a nice solder fillet. You need to leave a little bit of room. Millimeter or two is good enough. Don't leave them too long. Just looks bad when they're too long, but try to keep it consistent. It has no, you know, no functional reason. It's just more of a cosmetic thing. You know, the first thing that somebody does when you give them their amp back is they flip it over and they want to look at what you did. How'd this guy fix this thing? What did he do to it? If he looks at it and it looks like garbage, you know, the guy might start to think that your work is garbage. So there we go. We're heating up the solder sucker, and while we're doing that, I'm going to see if I have some of these caps that I'm missing. I hope I do. It is not looking good. I do have 35 volts, so for the time being, until I get the right ones in, we'll throw two 35 volts in there. Just so we'll be able to test when we're done. Alright. We are hot. So main caps, since this is on a ground plane, I like to just get it good and hot. And these ones I like to swirl around the pin. I don't go over the pin, I just swirl it around the pin. Especially where the, you know, on the ground plane. Sometimes you have to add a little extra solder. But just make sure you get it hot. Hot enough to get a good joint and a good fillet. You know, if you don't have a good fillet, suck a little bit off. Throw a little bit of fresh stuff on there. That little tiny bit of flux in there does help. Alright, here we go. Just drop it over the top, heat it up, lift it off. We're going to do that on all of them. Just make sure that where there's a big ground plane, you get a nice solder joint there. No cold solder joints. And then if there's not a ground plane there, you just get an even better joint. We still got to clip that guy. There's a ground connection. Nice, perfect fillet. So now we know that's soldered in good. The joint that goes between our resistor and the center leg of our transistor. Get that good and hot, flow it all together. This little leg that is barely poking through, make sure he's soldered in good. Now our big resistor. Heat that whole pad up, get it liquid. That's it. We are soldered in. So I'm going to go ahead and throw in those two under voltage rated caps just so we can test it. These are not going to stay in. They're only going to stay in just to power it up to prove that we got this thing working. And then after we do a test, I will throw the correct ones in my shopping cart and call it a night. And I'm not even going to worry about the polarity on these. I'm just going to throw them in there. They are bipolar. Doesn't matter. But I kind of feel like it would be wrong to go this far and not actually give it a test. And you never know. Maybe we'll find something crazy. Maybe it'll blow up. There's always the what if. Typically, these bipolars are used in the audio path. So, I'm not going to crank it up real loud. It should not be an issue. But the original schematic or the original design had 50 volts in there. We're going to replace it with 50 volts. That's what it calls. So if I had 100, I would put a 100-volt in there, but I do not have any of those either right now. No 100s and no 63s. But for a quick test, it'll be fine. Give it a quick once over, make sure we didn't short anything out, make sure we didn't miss anything. I left these leads untrimmed, so we'll trim those real quick. Alright, check our switches. We want to be in on, phase at 0, low pass at LFE, and gain all the way down. We'll check the fuse. I've never seen a blown fuse in one of these ever. Which is weird because with that resistor melting down. They're about to catch on fire. But let's see. See if we have a good fuse. I'll check the rating on it too, just for the heck of it. Fuse is good. I can't read the rating on it. I think that's original fuse. It looks like 5 amps. This fuse has been replaced at some point. No, we're at 6.3. We're good. 6.3 amps. That's what it's supposed to be. Fuse is happy. We're at 110 volts. Plug in our power supplies. I need a power cord. Now we are going to fire it up with a current limited supply. First test, I always do it, just in case something else is wrong. I need to get a longer cord. My cord is really short. Let me get a longer cord. I had a nice skinny testing cord, but I do not see it in my testing box. Oh, there it is. We're good. These little Velcro things, these cord wraps, these are awesome. If you've ever had any work done by me, you will be familiar with them, because I include one on every amp that has a cord. This is my favorite power cord. It's nice and skinny. Works good for the bunch. Remember, we're still switched off at this point. Alright. Let's put our amp with this. Nope. Alright, I will hook up our test woofer. You can see I still have not replaced these with insulated fast on connectors. It's on the to-do list. We'll get there eventually. Prop him up in the kickstand. I'm trying to come up with a creative way where I can actually give a visual of the audio output that we're getting. I think I'm going to do it with a small little tabletop oscilloscope, but we're not there yet. So in the meantime, at 1:15 a.m., we're just going to turn this thing on and see how mad the wife gets. Couple of light flashes as the power supply comes up. And we have sound. Let's go up. We're at 30 hertz right now. 50 hertz. Probably won't be able to hear it, but we're working good. I got to keep the volume at a reasonable level. If I draw more than 1 amp from the current limited supply, the amp will reset, but we have sound. I don't know how audible it is. You should be able to hear that. Nice, clean 50 hertz tone. So there you go. Power her down, let her bleed off. We have another successful amp repair. So just for the cliff notes on this guy, and let me flip my light back on here. So on the R-115 and 112SWs, power supply is generally good. Seems to be well built. Amp board is always your problem. First problem is going to be overheated, burned out resistor. Next problem is going to be capacitors that have thermal damage to them. And it's mainly going to be the ones that are around this resistor. So as long as you replace the resistor and do a recap, you should be able to bring this amp back to life. Alright, well, I appreciate anybody that was tuning in or is going to watch this video. I hope this helps somebody out. I'm going to try and get some more of these up. We'll do at least once a week, maybe more if we have time. I have a lot of them to go through, so hope you don't get bored, and we'll work through them. I'm looking at the shelf right now, and